Okay, we're going to be working problem number 28 from chapter 6. This is on page 310 of your textbook. It's a good basic problem on some conditional probability. I've written down the information they've given you in the problem stem about the probability of E, F, and then E and F. This little N symbol there does technically mean intersection, but we can think of it as just and, because in the South we know that means and. People go hunting, fishing all the time, hunting and fishing. So in will mean and, technically intersection. So it wants us first of all to find the probability of E given F. That notation means the probability of E occurring given that F occurring, or the probability of E occurring if you know that F has already occurred. Now, one thing some students try to do is they would just try to say, oh, if I've got the probability of E and the probability of F, I can just multiply these two probabilities to get the probability of E and F. And the first thing I want to point out is that if you multiply these two together, you get a 0.42, which is not equal to 0.54. So that shows you that sometimes if it's an independent event, you can get away with just multiplying, but in most cases in this stats class, you cannot assume that you just multiply the probabilities. So what we're going to do is we are going to use our conditional probability formula to find out what this is. Conditional probability, basically, I can say that this is equal to the probability. Since I know F is occurring, probability is always what I want compared to what I have. So I'm going to do a probability of F down at the bottom because I know for sure it's given that F's occurring. So that's my denominator. I know for sure F's occurring. And my numerator, I'm looking for E to occur in conjunction with F. So that is my numerator. So now I can get this answer very simply at this point by doing 0.54 divided by 0.6. And that's going to give you a good answer there. The second part for part B, it wants to know the probability of F given E. Now, the order these statements occur does matter because this time instead of knowing for sure F occurs, I know for sure that E occurs, so my denominator is going to be the probability of E. My numerator will still be the probability of F and E, which is going to be the same thing it was earlier. So now when I finish this problem up, I'm running out of room here, but it's going to be a 0.54 of my numerator, but this time my denominator will be a 0.7, and that's going to give me a slightly different answer. Of course, on both of these answers, you could type them in the calculator and get a decimal equivalent for each one.